So let's talk about tautologies. So here I give you a general definition. The compound statement is called a tautology if it's true for all truth value assignments for its compound statements, and it's called a contradiction when the truth values are all false for all compound statements. So, so we have TO representing tautologies and FO representing contradictions. And what we gotta know um, is that if P1, P2, P3, all the way to Pn, if they are all ones, then Q is one. If they are all ones, then that implies that Q is one. So this whole thing that we have here, this is called the argument. And I can't even draw a line because this shitty program keeps on erasing it. So this is called an argument. And these P's, what these P's are called, they are called premises. Premises. And this Q is what we call the conclusion. So the purpose of this is to try to show that conclusion Q follows from all these P's, to try to show that if each and every one of these P's is a true statement or is a 1, then Q is also true or is a 1. So yeah, if in this figure, if each of these are 1s, then under those circumstances, Q is also 1, and that implies that it's a tautology, and in that case, we have a valid argument. So, to give you an example of a truth table of tautology, this is what I stole from a book from Grimaldi, Discrete and Combinatorial Mathematics. It's a pretty old book, and I think it's pretty widely used around the world. But this is what we have. If everything's a 1, then that's called a tautology. And if everything's a 0, then that is what we call contradiction. And that is all I want to talk about for tautologies and contradictions. It's pretty simple. Pretty simple concept to grasp. If everything's a 1, then it's a tautology, and if everything's a 0, then it's a contradiction for compound statements. It's as simple as that, right? So that's all I want to go through today. Please rate, comment, subscribe if you haven't already, and to like us on Facebook, follow us on Twitter, and I'll see you guys again next time.